Hi folks, I'm excited to tell you that I've moved to a new studio. And man, I'm so happy. This has been a dream for me for the past couple of years. And it's funny, but I'm actually in the same building as before. I just moved down to the basement. Yeah, the only thing is I had to say goodbye to daylight, but of course, I do get a proper soundproofed studio in return, which is totally worth it in my opinion. So in today's video, I wanted to share my process of setting up in a new room. I did buy acoustic panels from the previous owner, so a lot of work has already been done, but still, you only know for sure once you start measuring and listening, of course. But the same workflow applies to an untreated room as well. You first need to decide where you're going to sit and where to place your speakers. So, without further ado, let me show you my process. Alright, so I've got Room EQ Wizard right here. I'll leave a link in the description. This is a free program and this is great for measuring acoustics, but also speakers, even electronics. So let's start by going to the preferences. And here you need to select your audio interface and an output and input. And on Windows on ACO mode, you can only test one speaker at a time. But yeah, that's something you want to do anyways. So I've got it set to output 1 and I've got my measuring microphone connected to input 1 as well. And then here's something you can do. You can set a timing reference. So you've got several options for that. In this case, you literally connect a jack cable or an XLR cable from the output back to the input. So you create a loop. So then the software measures the latency. And that's useful if you want to make several measurements. So you can line them up properly later on. But before we even start measuring, we also need to measure the sound card. So if you go to calibrate, you've got some instructions right here. I'm just going to press next. So it's going to output a 1 kilohertz sine wave. So now I'm just going to connect a cable from output 1 back to input 1. So we can measure the sound card. Alright, so I'll turn up my output level all the way. And I need to match the output right here with the input gain. So the input on the preamp. Right, about right. In this case, for this video, I'm not going to use the reference input because I've got my microphone connected to that input channel. So just ignore that one. Right, so when I press next, it's going to make a measurement of the sound card. Right, so as you can see, we've got the frequency at the bottom and the level on the vertical axis. And yeah, it's pretty flat. It's only a slight dip at the higher frequencies above 10K. But now the software can apply this curve in reverse basically. So you're always measuring without the interference of the sound card. So that's really useful. So now I just need to press make call. And then I can enter some notes if I want, but I'm just gonna store it. Save. And now it's selected right here. You can also press browse to browse other calibration files. But now we're set up to record, so I'm just going to remove the jack cable and reinsert the microphone. Alright, so now I need to check my levels. First of all, I'm going to go right here, press the arrow and select use main speakers to test signal. Yeah, now I need to turn on my speakers and I've got a decibel meter right here. So a sound pressure level meter, but you can also use a phone app. It's not that important, it's just to compare the different measurements, because you don't want to change your levels if you're comparing stuff. So keep that in mind. Set your levels once and then don't touch them again. But what I want to do is change the curve to dBc. I hope you can see that on the camera, but so it measures an average signal. And I'm also going to change the speed from fast to slow. Right, so now let me turn up the monitor control. Right, so I've put it on 75 decibels, dBc. It really depends on the size of your room, how loud you want to measure. But this sounds fine to me. Yeah, and of course then I just need to turn up the gain on my audio interface. So I'll try to aim for -20 dBFS. There should be plenty of headroom. So yeah, around there. So I've calibrated the level. I can remove this measurement. If you go back, by the way, to SPL Meter, You can also calibrate the built-in SPL meter. So just press calibrate, use a speaker calibration signal. Well, I know it's set to 75, so I'll just press OK. So now the built-in SPL meter corresponds to the hardware SPL meter. I've shown you before that you can use a loopback as a timing reference, but on my interface I only have 2 outputs and I've got both speakers connected. So I'm instead gonna use an acoustic timing reference. So it's just gonna add a short beep at the start of the measurement, so it lines up all the measurements later on. You can select the start and the end frequency and also the length. And I usually keep this a little higher so it can really measure all the room modes correctly. Alright, so output 1, the left speaker, yeah, that timing reference doesn't really matter in this case. Input 1, that's where my microphone is at. You can also set a start delay, so if you want to walk away to another room in the meantime, I'm just gonna set it to 1 second. Alright, and then we can press start measure. Oh yeah, by the way, if you're taking measurements, make sure that the pot meters on the rear of your speakers are all set to the default position. So there's no EQ active, it's all set to the default. Alright, but now let's press start measuring. Alright, by the way, I'm just gonna make one more. I'm gonna back away from the microphone a little bit because I don't want to influence the recording that much. That's where the start delay is really useful for. If you set it to 3 seconds, you can safely walk away from your computer. Alright, so we've made our first measurement of the left speaker. So the first thing I'm gonna do is rename this file to left only. And in this case, I'm gonna change the tab to all sound pressure level. I'm gonna make sure the range is set from 20 Hz to 20 kHz. And then if I go to controls, I can add some smoothing. It's a bit easier to see what's going on. To make it simple, I'm just gonna use 1/12 smoothing. Alright, so now you can see the frequency response at this speaker position and at this microphone position. So I'm just gonna repeat this, but with the right speaker. So I'm gonna go back to settings and I'm gonna change the output to output 2. Okay, go back to measure and let's try that again. Right, go to controls. Let's set it to 1/12 smoothing as well. Right, so now we can compare the left and the right speaker. So on the bottom, you can enable or disable either of the measurements. You can see the SPL, so the average sound pressure level is around 75. And you can see there are some peaks, there are some dips, but this room is already treated. The most important thing is that it's currently empty, of course, but it's also really important to find the right speaker position. Just a quick side note, but when you're looking for the best listening position, one position to avoid is exactly in the middle of the room. That's because the majority of the room modes add up right in the middle. So you better move a bit more towards the front wall. But how far exactly? Well, that's something you need to measure. The first thing I'm noticing is that the first little peak and dip is pretty similar in both speakers. Probably because the speakers are the same distance from the front wall. So if I want to get rid of this peak and this dip, I may need to experiment with the position from the front wall. So maybe move away from it or maybe towards it. So let's try that first. I'm first gonna move towards the wall. Oh, and by the way, I usually mark the position of the speaker stand with a piece of tape. So I can always measure the distance later on. And I can always go back to a previous position easily. I do the same with the microphone, by the way. Alright, so I moved the speakers back, I think a little over maybe 2 feet. So let's measure that again. You can also change the output right here on this measurement screen. Do the same thing for the right speaker. Okay, and let's compare that. So let me compare only the left speaker. I only moved it towards the wall. I haven't moved it left and right. So as you can see, the peak right here is really starting to grow. So that's definitely a room mode in the length. So the pressure maximum is at the border of the wall. So in this case, moving the speakers towards the wall isn't the best option. But yeah, again, there are really no rules. This is just something you need to try for your room. Maybe it works. In my previous room, it worked really well to move the speakers towards the wall. But yeah, measurements don't lie. So just measure. And of course, at the end, always listen as well. But what else can we see from this movement? This dip right here is pretty huge. But this dip did get fixed. So maybe we need to move somewhere in between. There's a huge dip right here as well. Now let's compare the right speaker. So if we compare left and right again, you can see this peak stays the same. So that's again a confirmation that this is a length room mode. That's something we need to fix either way. This dip is also in both speakers. So that really needs to be the change we just made, because it wasn't as strong in the previous measurement. Yeah, let's try what happens if we keep this position towards the front wall, but we reduce the width. So we move the speakers closer together. And by the way, I'm just gonna take a tape measure and measure the distance. So I can write that down right here in the notes section. So distance front wall, 60 centimeters. And on this one, it was 106. Oh, and let's also measure the distance to the left wall or the outer wall on both speakers. All right, I'm just gonna save all measurements just to be sure. Okay, let's go to the left speaker. So left inwards and the previous measurement. So this peak at 75 Hertz changed a bit. What else? This peak changed a bit. So green is the later version, the current version. And this peak here improved a lot. Let's compare that to the first version as well. So yeah, this peak is really not caused by the width, mainly with the length of the room. But this is caused by the width, this one. Okay, let's see on the right speaker. There's still a huge dip right here, and it's present in all but the first one. So that's probably moving closer to the wall that affected that. But in terms of width, not much has changed. Only this peak right here. So the average is of course 75 decibels. We probably need to improve this some more. So what can I test right now? I can either move the speakers towards me again, or maybe more to the outsides of the room. Yeah, if we compare orange, so the previous one, to the inwards one in blue, which is better? I think the previous one was a little bit better, except for the left speaker, because here it got rid of this dip. So what I can do is leave the left speaker as is and just move the right speakers towards the right wall. But yeah, first let me put some more tape on the floor so I know where I started. Alright, so I've walked around the room and I've noticed that in the back of the room there's a little bit more low end. And it lacks low end in the current position. So I'm just gonna make some measurements, moving the microphone backwards to the rear wall. But first let me make a measurement with both speakers. I haven't done that yet. On Windows, if you change the driver to Java, you should be able to select both speakers. Output device, Focusrite, left plus right. Okay, and let me change the input as well. Default input, left input. Okay, let's measure that first. Same position, just with two speakers. Yeah, so that's a little bit louder, of course. Yeah, it's this area. There's a little bit of a dip. Let's see if that comes from the speaker position or from the microphone position. So let's move it back. I'll start with half a meter or something. Okay, so if we move it back, what is this? 94 Hertz. There's a little dip. And this peak increases a bit. This one is reduced. The next one, there's a new peak right here. Yeah, you mainly want to look below 200 Hertz. That's where the most of the low-end issues are. So is this an improvement? I don't think so. So in this case, it's not a listening position problem, but a speaker positioning problem. So that's good to know. Now we can narrow things down. But just to test it, let me also move the microphone completely back towards the rear wall, because I'm curious how that sounds. Okay, so the overall level is a bit lower because the distance is greater to the speakers. This dip increases. It's pretty much everywhere. So it might be the width. I haven't tested that yet. But yeah, we do get some more low end around 50 Hertz. So that's probably a resonance. I'm not sure entirely yet. We also can't see everything from this view. There's also a different view called the Waterfall Plot. It might be useful to take a look at that right now. Just press generate. You can set the range from 10 Hertz to 200 Hertz. And this shows the length of the room modes basically, or the resonances. So we might need to change the scale a little bit. So you can change the level, the frequency, but also the length. So go to controls, time range. Let's set it to 600. Okay, so it's actually not bad. This room is already treated with some membrane absorbers, a lot actually. So it's not bad at all. Just one long one. Oh, and of course this is the rear wall. So we need to make a new plot for all the measurements. So select position 1, press generate again. So in the depth, so if you look at this line right here, that's 100 milliseconds, 200, 300. And for most rooms, if you are below 300 milliseconds, that's a pretty good situation to be in. So there aren't as much room modes left. So we just need to dial in or reduce these peaks somehow. And yeah, there are of course other tabs you can show, like this one, the decay. Look, I'm not an acoustics expert, but sometimes this helps to clarify things a bit more. Yeah, this is also really useful. So there's a hotspot right here, 74 Hertz, and a dip right here. But yeah, let me just go back to position 1 with the microphone and let's move towards the left and towards the right. Oh, by the way, I changed the smoothing to 1/6. It's a bit easier to see. So position 1 and then towards the right. So there's some new dips. This one is filled, this dip. But overall, there are more dips than before. If we move to the left, it looks maybe a bit flatter, but here's a dip. This dip is filled a little bit more. So yeah, is this a better option? That's a good question. In the end, it's all kind of averaging out a little bit. So you will never get it perfect. You're trying to make it as close as it can be. By the way, if you go to controls, there's also a psychoacoustic smoothing option. So this is how we are hearing it in the end. And if you now take a look, so the first position and towards the left, then maybe moving towards the left a little bit isn't a bad decision. So yeah, let's move to the left and maybe then move the speakers as well. And one tip, by the way, make sure your frequency plot is set to the right frequency limits. So 15 to 20 kilohertz, and then yeah, maybe reduce the maximum and minimum values a little bit. So it's easier to see what's going on. All right, so I made a lot of measurements, but eventually I ended up at the same spot as I started at, which was still the best spot. But there was one issue, and that's this little dip at 1 kilohertz. And I couldn't figure out where it came from. I couldn't hear it when I played back white noise or music. But then I realized the microphone I'm using, it says it's omnidirectional, but of course only up to a certain frequency. Because at a certain point, the microphone capsule or the microphone design will start to get in the way of the frequencies. And that's exactly what's happening right here. I made a new measurement by just rotating the microphone forward instead of up. And now you can see this dip is gone. So that's important to keep in mind if you're using a measurement microphones like this one. It's fine to point it upwards for the lower frequencies, but if you want to get some accurate measurements in the high end, point it in the middle or towards the speaker. But yeah, of course above a certain frequency, again 10 kilohertz or something, I don't think it's really accurate. But yeah, that's something we can easily tweak with EQ if we want to. But yeah, I think it doesn't sound bad. I just want to fix this little dip right here at 100 hertz. In my previous studio I had a huge peak of I believe even 15 decibels. So this is a better option. But still, I think it can be improved a little bit by moving some panels around, maybe adding some more pedals. And I can always add some EQ after the fact, which I might show you in another video, because I've got a really cool device for that. Alright, I think that's it for now. Alright, that took a while. The funny thing is, after all this measuring and moving speakers, the first position was actually the best sounding position. But measurements never lie, so it depends entirely on the room. Just try it out in your situation. In the end, the speaker and listening position are going to make the biggest difference. Even when you've spent a fortune on acoustic treatment. There's still a lot of work to be done in this studio, so stay tuned for more studio updates. Let me know if you have any questions in the meantime, and I'll see you all next week with another tutorial.